All right, welcome to Computer Science 2. I'm Dr. Chris Burke. Most of you have met me. I've met most of you. This is specifically CSCE 156H. This is the honors section of Computer Science 2 for the UNL campus. I've got two other sections of this course, one of them up at UNO. So if I ever screw up and mention another section, you can forget about it. Just pay attention to your own section. Anyway, today we are doing a course introduction, and then we're going to get started immediately on Python. If you've got Python experience, great. If you don't have Java experience, you're going to need it. So you might want to supplement the first 3 weeks here by watching the live stream or attending the lecture in the main section, which occurs right before this, over in Pound, the same building, 102. Or are we in 102? We're in 101. Whatever the other one is. All right, so today we're going to give a course overview. And remember, I am live streaming. I live stream all my courses, so this will be available as a recording on YouTube immediately after. If you want to, you can go ahead and sign in and join the chat. I usually look over and see if anybody's asking any questions or contribute if you want to. Otherwise, let's go ahead and give a course introduction. Then we'll go over the schedule, how we're graded for this course, which is project-based, and other resources. So thematically, theme-wise, at the end of a Computer Science 1 course, you should be able to approach a problem and design what's called a top-down solution. That is, you take the problem and you break it up into smaller and smaller chunks until either, well, that's just one line of code, or that's a function that I can use out of the standard library. And then by breaking it down into smaller and smaller chunks until each one of those is solved, the problem that you're trying to solve at a higher level, it's been solved. And then, of course, you should be able to code that in a high-level programming language because, as Douglas Adams said, by the time that you've sorted out a complicated idea into small little steps that even a stupid machine can deal with, then you've learned something about it yourself. You've solved the problem, right? The key realizations that you should have about that are that computers are not problem solvers, right? You are, right? We're still humans. Humans still rule this planet, right? Computers are dumb. Even the fanciest, schmanciest of AI out there right now, it's still dumb. All it can do is regurgitate what it's been trained on, right? Things that humans have created. They do exactly what they're told. There are no ghosts in the machine, right? Programs only automate solutions. Computers are very good about processing large amounts of data very quickly. Humans are not good about that. But computers do not solve problems. Humans are still a part of that equation. Right? In contrast, at the end of Computer Science 2, you should be able to approach a reasonably complex problem, and instead of designing a top-down solution immediately, you should stop and ask yourself questions first. Design questions. What entities or objects would be appropriate to model this problem? How would these objects that I've designed, how would they interact with each other? What data structures can I pull off the shelf and just immediately use to solve the problem without having to worry about it any further? By the end of this course, we'll be looking at something called heap sort, which is very dumb code. There's this data structure called a heap, and if you put everything into it, and then if you take everything out of it, it's sorted, right? All the magic is done inside of that data structure. Smart data structures and dumb code, put stuff in, take stuff out, are a lot better than the other way around. Really smart, clever code, something like quicksort or merge sort, right? Which is very, very easy to get wrong, right? If you just use a data structure, put stuff in, take stuff out, and you got the data structure correct, that's much, much better, right? It's fundamentally a different problem approach. It's a bottom-up approach. You're asking yourself, what are the building blocks that I need first to combine to solve this problem instead of breaking the problem down into the smaller chunks. Right? Our approximate schedule for this course is going to be broken out into 15 weeks. The first 3 weeks, we're going to introduce Python. This is the H section. If you've already got Python, you can ignore me, or you can tell me I'm wrong when I cover Python because it's not my first programming language. What is the phrase? Jack of all trades, but master in none, or something like that. Right? So if you don't have any Java experience, we will be using Java weeks 3 and beyond. Right? So you do need some Java background. That's assumed if you're coming from 155H. But if you're not coming from 155H, If you had it in high school, great. You might want to supplement that with what we do in lecture. If you just want a review of it from 155H, then you can follow along in the main lecture. If you don't have a Java background, I would highly recommend you do the first 3 labs in Java and the first assignment in Java. If you do have a Java background already, I highly recommend that you do it in Python. Right? We're not going to check. The grader accommodates both, just not, I'll do the first problem in Java and then I'll do the second problem in Python. Don't mix it like that. It's got to be all Java or all Python. Otherwise, we get into object-oriented programming within the context of Java. Then we do database design and introduce another programming language called SQL. It's a declarative language. It's used to query a database, a relational database system. So you'll be pulling data out, putting data in, manipulating data, all that stuff. Then we'll connect up our database that we design and create through our code, Java code, by covering database connectivity. Then we get into, in the last third of the course, we get into data structures and algorithms. List-based data structures, algorithms, algorithm analysis, searching and sorting, stacks and queues, trees, heaps, binary search trees. Right? That's your introduction to data structures and algorithms. If you look ahead all the way to Computer Science 3, either this summer or next year, that's CSE 310, then you'll continue with data structures and algorithms. Right? Your labs are 20% of your grade. Right? Your assignments are 80% of your grade. What does that mean? That 0% of your grade? Exams, quizzes, right? Participation, attendance, reading, right? None of that stuff is graded as part of this course, right? So oftentimes I'll do that in Computer Science 1, just because that's your first course. You need to get acclimatized to college or whatever. But now everything is in your hands, right? There are no exams. There are 14 labs. We dropped the lowest one, so in actuality, there are 13 graded labs. Each one is worth 20 points for about 20% of your grade. You get starter code provided off of GitHub. You check it out. You finish whatever classes we give you, whatever starter code we give you, you finish it out. You run your JUnit tests. You'll go through this in Lab 1. A very simple program. It's designed to walk you through, code a little bit of this. We tell you exactly how. Now go ahead and run your JUnit test. 100% pass, great. Now go ahead and hand it in through the web hand-in. For those coming from 155H, it is not CodePost. CodePost does not support everything that we were doing, so we're going to have to revert back to the web hand-in and the web grader. But you'll go through that process in Lab 1. And then you can then run it on the web grader. You see, oh yeah, everything is still passing. You get your 20 points. If there are 50 tests and 49 of them pass, that means one of them failed. That means go back, fix it, hand it in again. Repeat that process as many times as you want up until midnight, the due date. For all labs, for all assignments, right? Otherwise, for labs, it's based on completion, and 49 out of 50 ain't complete. So make sure that you're completing all those JUnit tests, right? They can be completed asynchronously, by the way, meaning that you can go ahead and get started right now. We do not grade. We do take attendance to track performance, but we're not going to grade on it, right? And by the way, unfortunately, I didn't fix this from the last one. There is no Zoom option, right? Everything is now in person. There's no online section for this course anymore. But otherwise, if you go to your lab session, when you go to your lab session, because you're going to go to it at least for the first half of the course until you get used to everything, you'll be teamed up with at least one other person, right? You can work you can work in a group of 3, right? If you want to work of 4, the communication kind of gets difficult there. So I wouldn't recommend that. You can work alone if you want to, right? We will team you up if you want to partner and you just don't know anybody because you're new to the class, right? But otherwise, there are LAs, learning assistants, there to help you with your labs. Right? In fact, there are learning assistants that hold 50 help hours throughout the entire week. Right? Assignments are 80% of your grade. Assignment 1 is 3 basic programs, not in Java, but in Python. Unless you don't have any Java experience, then you can do it in Java. It's individual, no partners, no collaboration at all, right? You can talk at a very high level with the person next to you. What the hell does that error message mean? Or why is this not compiling? You forgot your semicolon, right? That kind of collaboration is fine, but you got to write it on your own. You got to prove that you've met the prerequisite for this course. After that, you can team up with one other person. So we do allow pairs. In fact, we encourage pairs. But otherwise, the assignments after that, in fact, anybody from 155E or 155H, you will recognize these 3 basic programs because I just took them from that course. from the exams, exam 1, 2, and the final exam, right? But you'll be doing them in a new language. So if you've already solved it, great. Now you'll solve it in a new language. But otherwise, assignments 2 through 7 are a semester-long project. Each one of these phases builds on each other. The first phase, you are doing your basic object design in EDI, electronic data interchange. You're reading from a bunch of CSV files, and then you're converting them to JSON and XML. Then you design your application and implementation to produce a bunch of reports. The theme this year is a wireless retail sales system. So I forget who, it's all just fake names put in, but they are consolidating all these wireless stores together, and they sell phones and phone accessories, they sell data plans and voice plans and other types of products. And you're responsible for designing and implementing their sales system. Right? Then you get down into the database design to support that application. Then you will write code, Java code, to load data from that database instead of that CSV file. And then you will write code to persist or save stuff to that database. Then you'll design an ADT, a sorted list ADT, and integrate it with your project. The last assignment 8 is written. It's theory, it's math, it's data structures, algorithm analysis. Right? So you'll be writing that by hand. Or if you really want to, learn LaTeX and then type it up in LaTeX. That's not required. Otherwise, you could do it in hand, take a photo of it with for each page, and then hand it in as a PDF. Right? That's long in the future there. So the project phases, again, it's project-based. It's a multi-phase themed project. At the start, each phase is graded based on correctness and design. We do grade on documentation and style, but those are a minuscule amount, like 5 points each. We have a living design document that is due 1 week prior to each phase. What that is, the purpose of that is that you are giving us a draft of what you plan on designing and implementing. Then we take your design document, we grade it, right? I'm putting that in quotes there, and give you feedback on your design. No, we foresee a problem doing it like this, or that's not really how you do it in an object. You're going to have a problem doing it like this if you stick with this this table design or whatever, right? So we're going to give you feedback on that you can use to change your design as you implement it. Because if you have a bad design in phase 1, you're going to be eating your own dog food in phase 2 and 3 and 4 and 5, right? That you'll just be fighting that design, or ideally you go back and you fix it so that you're not fighting your design. Right? Each draft is graded and feedback is given. It's graded based on completion. You give us the draft, you get your 5 points. Small amount, right? Only the final draft at the end of the semester will count towards your grade for the contents of the design document. We'll have more details on this in week 3 or 4, or 4 or 5, when I invite somebody from the UNL Writing Center to come in, and we talk about technical writing and how to go about doing technical writing. You're not writing poetry, right? You're not writing a lot. In fact, the crux of technical writing is write as little as possible, right? So ideally, your design document in the end is going to be like 6, 7, 8 pages at most. And most of that's going to be like boilerplate template stuff, right? Which you follow. We give you a Word document version, and we give you a LaTeX version if you want to learn LaTeX. Otherwise, just stick with Word. Right? LaTeX is a very good skill to have. It's not really world applicable unless you're in academia, but it is a much better typesetting system than Word ever will be. Right? So when it comes to after the first assignment and you need to decide whether or not you're going to get into a pair, right? You can choose whomever you want. Pairs, right? 3, 4, 5, definitely not. The work gets just too diluted and it's too easy for somebody to do nothing in a group of 3, right? But beyond that, even outside your pairing, you can discuss at a high level with other teams. Right. Well, we went with a single inheritance design like you talked about in class. And we did it for this reason and this reason and this reason. Oh, great. You've convinced me. I'm going to go ahead and do that. Right. Or, well, I named my class this instead of that because of that, these reasons. Right. You can talk at a high level like that, but the code and the work has to be your own. When you do team up in a pair, it's got to be an equal amount. It's not just you do phase one, I do phase two, and then we piggyback and go back and forth. Or you do this part of phase one and I'll do this part of phase two. You can do that as long as you're coming together at some point and merging your ideas together and discussing it, right? It's easy to bounce ideas off of somebody else. We talk about rubber duck debugging in Computer Science 1, right? Where if you don't have anybody, try to explain it to a rubber duck sitting on the top of your computer. The very act of you going through and trying to explain it to somebody or something, right, usually works itself out. Oh yeah, now I realize what I was doing wrong, right? If you've got another person sitting in front of you and you're bouncing ideas off of each other, then it's even more interactive, right? You're not just talking to a rubber duck. Now you're talking to somebody who said, that doesn't make any sense, or, well, that's a good idea, but have you thought about this, right? And it's a good way to develop your soft skills. Soft skills are something that's difficult to teach, but it's easy to learn if you go through the process and the experience. We're talking about communication, teamwork, right? Scheduling, and at the end of the day, conflict resolution. Conflict resolution where, you know what, this partnership isn't working out. How do I have that tough conversation with my partner to say, I think that we need to part ways here, and here's the code that we worked on up to this point. Good luck, right? Having that, or putting an ultimatum, right? You haven't been showing up to the last 3 meetings. You know, I really need you to show up the next meeting, otherwise we're going to have to, part ways, right? That kind of conflict resolution, not just you suck, I'm going, right? Don't do that. Don't do something like that. Build up those reasonable soft skills, right? But be careful. Again, that's a possibility that you have to have those conflict resolution skills, because partners can mooch, they can flake out, they can just disappear, right? Choosing to work in a pair means that you are now responsible for not just yourself, but your partner, right? You can change pairs if it's not working out. You don't have to tell me, right? The way that you're doing this is by going onto Canvas and joining a pairing, right? Make sure that you're doing that not for the first assignment, but for the second assignment and beyond. If you won't need to leave that pair, you can do that as well, right? We use that pairing on Canvas for our auto grading so that, yep, those two are paired up. We're going to grade one of those submissions. We're not going to grade 2 submissions and double up on our time. Don't undermine the learning process of your partner, right? And what I mean by that is, yeah, you shouldn't mooch, but on the other hand, you shouldn't allow mooching, right? You should not allow your partner, you should not be doing all the work, right? You should be involving your partner and making sure that they're doing an equal amount, right? Don't just, I'm confident enough, I can do this on my own. If that's the case, then work alone, right? That's always an option. Right? Otherwise, use Git. I shouldn't have to say this in 2024, but don't pass things through a thumbnail drive or email or Dropbox or something like that. Use Git, right? We covered it briefly in all the essential things that you need for Git in Computer Science 1. I have a video on it. Video is 0.2, right, that walks you through the process of using Git in Eclipse. Review that video if you need to. Right? The use of AI tools is prohibited. I did that in Computer Science 1 as well, but I also gave access to this thing called CodeApp. How many people used it? Okay, 1 person. Yep. I didn't have to pay a single dollar to the API because nobody else used it, because the usage was so low. So I will take that to mean that everybody chose not to use AI at all, right? And that they did all the work on their own, right? But otherwise, the use of AI tools is prohibited here. If you want to use CodeApp, we might look into it again, but I think only like a dozen people used it, and maybe 2 or 3 times. So I'm not gonna go through the work of setting it up again if people aren't going to use it. But if you want to use it, then let me know and we can work something out. Otherwise, take the long view for this course, right? What I would recommend that you do today is read the handouts. In fact, I'm giving you this as a resource. This thing is called a Gantt chart. So in real life, in fact, Gantt charts are over 100 years old, 150 years old or something. It is a way of organizing and scheduling a project. I've adapted it for you to use to organize and schedule your semester with respect to this class. So what this is a breakdown of major milestones, assignment 1, assignment 2, assignment 3, and each individual part of that. For example, reading, I can zoom in on this, reading and understanding the handout. It's not going to take you 3 days, but I've scheduled it for 3 days. Right? Once you've read and understood the handout, mark it down, 100%. I only read the first half, 50%, right? It gives you progress as you chart through this. The red shows you what today is. If you opened this up tomorrow, the red would be highlighted on this Tuesday instead, right? As you go through the semester, follow this chart. If you need this, if you have your own way of self-organizing, great, use it. But this is a way of organizing the project throughout the semester. Lab 1 is on Wednesday. You got one day to do that. You do it ahead of time, great. Go ahead and mark it down, and it's done. You see how that automatically updates? This gives you an idea of, am I ahead? Am I behind? Right? If you want to, go ahead and change it. This is not something that you hand in. It's not something you're graded on. It's not something I ever want to see. Right? It is a tool for you to use if you need it, if you want to use it. Right? If you say, okay, well, I need to break that up into two things, reading and understanding the handout. They go hand in hand. In my book, that's why I put them there, put them like this. Or say designing your test cases. You should start doing that next week on Monday, even though it's due Friday the next week, right? Why? Because, well, that's just what I put here. If you want to start on the weekend, note here I've not scheduled any work for the weekends. But if you like working over the weekend, go ahead and do it, right? Change it to 1/28 instead. There we go. It shifts everything automatically. Everything is based on what happened before. And you can see that it goes linearly throughout this the semester, this project, right? If I zoom out here, you can see that it's kind of self-explanatory. That a couple weeks from now, you'll be right here, and you can see, am I ahead or am I behind? Right? I gave you the first half of the semester for free. Once you get if you use this, once you get the hang of it, you can go ahead and design your own semester after that. Right? You'll find, no, it doesn't take me 3 days to read the handout. It doesn't take me 3 days to do test cases because I'm using some automated tool. Right? It's only going to take me 1 day to do that, so plan it out that way. Right? That's a Gantt chart. Take the long view. Right? Take a look at something like this and see, yeah, that's a lot of work by the end of the semester. But don't worry, it's over 15 weeks. Right? Start early. Again, that's why I put the Gantt chart in there. Have a good, well thought out design on paper, in other words, your design document, before you start coding. Design your test cases before you're coding. In fact, you're required to do it as part of the H section. On every assignment, there's a little bit of bonus. That bonus is required for the honors section. Part of the bonus for the first 2 phases is designing test cases a week ahead of time and handing them in. I have the H section do that because what I do is I grab those test cases and I use them to grade everybody, right? So that is worth bonus points if people in the main section do it. It's required for the H section, right? And by the way, designing a test case should not be all that arduous. There are plenty of tools out there to do it. We give you plenty of tools. Macaru or testdata.com or something, whatever it is, right? Oops, sorry. Yeah, there we go, down there. Use proper debugging techniques. If you did debugging in Eclipse last semester, great. If you haven't done it or you need a refresher, I've got videos on it and how to use it. And I'll demonstrate how to use it maybe later on as well. Keep in mind that smart data structures and dumb code are a lot better than the other way around. It is far more important in this course to think about design first and foremost than it is to implement something. If you have a good design thought out on a piece of paper in your head, the amount of coding that you do is actually minuscule, right? So in computer science, one, it might be lots of coding and then design as an afterthought, but that's the opposite of this course. If you put in effort up front and invest your time in thinking about it, the amount of time that you'll have to actually code is much, much smaller. Right? That's called technical debt. If you don't do that, you don't think about a design up front, and you just do it really quickly just to get it done, right? Then you've taken out a loan on your future time, right? Because you're going to have to find time to do it over if you don't do it the first time. Right? Or you'll be living with a bad design in phases 2, 3, 4, right? Also ask questions. Attend help hours early. Don't wait till the Friday that something is due, because I can guarantee you it will be full and there are only 2 LAs at that time. You will not be able to get any help at that time, right? Ask an LA for feedback on your design. That's the design document, but you can always take your design to an LA and say, hey, look at this. What's wrong with it, right? In fact, I did when I was holding office hours last semester. One of my LAs for CS1 was taking CS2. He said, "Could you take a look at my database design?" And go, "That's wrong, that's wrong, and that's wrong." Right? And getting and here's why, and here's why. Right? So get feedback in your design as early as possible. That's only possible if you plan ahead and start early or start appropriately, okay? And spread your time out over time. Otherwise, technical debt. You took out a loan, you got to pay it back with interest. Right? I can guarantee you it'll take even more time later on. Right? Resources, everybody should be in Canvas. Everybody should be on Piazza. You received an invite for it already through whatever email was on your Canvas account. At the end of each semester, at the end of each week, I post a retrospective. At the beginning of each week, I post what we're going to do that week, along with resources. For example, Lab 1 is due on Wednesday, and here's the right URL for the hand-in. Here's the right URL for the grader. It's been changed because they no longer allow us to use CSE credentials or CSE accounts. Otherwise, there's a full video for the Java version. There's a full video walkthrough for the first lab. It's kind of the same for the Python version, but a little bit different. Right? You can ask questions anonymous. Anybody not familiar with Piazza? All right, good. You can ask questions anonymously. You can ask questions so that we know who you are, but nobody else does. You can ask questions privately so that no student sees them. If you ask us to look at your submission or something like that, don't post anonymously. We're just going to say, who the hell are you? Right? And then you'll have to post again. Right? Otherwise, other resources would include the LAs, pre-prepared videos. If you take a look at the Canvas course for this, the Canvas page for this course, you'll see getting help. Right? We've got a dozen LAs. Now, the ones that are going to be posted here are only for this section. You only have 3 LAs for this section, but it doesn't matter. You can go to any LA's help hours. For example, right now, Umarov and Alex are over there in Avery 15 is where they all are. Otherwise, we've got dozens of help hours throughout the week. Again, probably want to stay away from those late Friday hours. And even though something is due at midnight, there ain't nobody there. Right? I too hold my help hours over in Avery 15, Monday, Wednesday, 1 to 2. So I'll be over there as well, right? Just like last semester, although different time. I think I don't remember last year. Otherwise, some additional course information here, other resources, check those out when you have time. Here's week 1. It's organized into Monday, Wednesday, Friday. When this is done, the live stream recording will be posted here. Otherwise, you could just look at YouTube immediately. There's Lab 1. There's the syllabus. There's the Gantt chart. There's getting started videos 0.1 through 0.3, mostly for the Java version, but it will help you if you don't know how to do get through Eclipse, or a video with 0.3 is actually relevant for how to create your project, but that's in a few weeks, so you don't need to necessarily watch that right now. If you do not have Java experience, there are 13 pre-prepared videos there that walk you through Java. Right? When we get to databases, I've got 8 videos on SQL and database design. I've also got my textbook, which is Computer Science 2. Right? I don't have chapters on Java. I don't have chapters on object-oriented programming languages or object-oriented programming, but I do have chapters on databases and SQL, lists and list-based data structures, algorithms and algorithm analysis, and tree-based data structures. That is a PDF. It is free. There is no other required course book for this course. There is no Zybook for this course. Right? Questions so far? No? All right, so rubrics and if you take a look at all the handouts, everything is served on GitHub, by the way. Actually, at this point, let's look at the syllabus. Where is it? Right there. There we go. So it's 156, but it's got a subsection for the honors section. There's the theme of the course by Eric S. Raymond. Smart data structures and dumb code are a lot better than the other way around. Right? You need Math 106 for this, and we're not going to be doing any calc, no derivatives, no Riemann sums or anything like that. It's just a general mathematical maturity, and whether or not it's actually needed is questionable. But you do need a good grade coming out of 155. Right? You need exposure. You need good working knowledge of at least one high-level programming language, whether or not that's Python. Yes? No? Okay. Java? C? Anything else? This is your time to brag. Lua? No Roblox, folks? Okay, never mind. All right, anyway, this is 4 credit hours. There's the actual listing. This is, of course, a prerequisite for Computer Science 3, Data Structures and Algorithms, and you do need a C or better to move on. Right? There is a 310H section in the fall. I don't teach it currently. I don't know who's going to teach it next year. Maybe me. Who knows? University policies, resources, services. If you need to be registered with SSD, services for students with disabilities, or anything else, counseling and psychological services, CAPS, all that information can be found here. Learning objectives, tentative topics. There's the assessment. It's not 1,250. It is actually a little bit more for the H section because, again, there are some bonus points that are required for the H section. Right? There it is. There's the spiel. Otherwise, there's the letter grade distribution, standard letter grade distribution, pluses and minuses. Labs, assignments talked about. 15th week policy notification that your last assignment and your last lab is due during the dead week. At the Friday of dead week, the course is done. There is no final for this course, therefore, the final that's scheduled, who cares? Right? If you have a question about grading, make sure that you post it or you ask the LA that graded your stuff. I will not be grading anything on the Lincoln campus because I have less support up in Omaha, so I'm doing more grading up there. But it's all the same assignments, and I direct the grading for all the LAs. But make sure that you're asking them first, and then you can come to me if you can't get it resolved. No late work accepted. The web grader policy and the late work policy are very similar. You hand something in, you grade it. It fails. It tells you why it failed. Go back, fix it. Hand it in again. Run the web grader again. Do that as many times as you want. 50 times, 100 times, 1,000 times. As many times as you want up until the due date, at which time it closes, right? It's got to work in the web grader. If it doesn't work in the web grader, there's nothing we can do. We can't grade it, right? Academic integrity, make sure that everything is your own work and don't use any AI tools, right? There's an honor section. Again, we will be going a little bit faster. We'll be covering a different programming language in the first few weeks. Python, it used to be PHP. I used to like covering PHP just to show how terrible of a programming language it was. But then there was enough demand, hey, we should be doing Python, fine. All right, let's do Python. But otherwise, bottom line, there will be higher expectations. There are bonus points that are required, right? There may be opportunity for bonus points later on, but we'll also be covering, as time permits, more advanced topics. Generally, like maybe some security stuff, maybe some TCP/IP stack stuff, maybe some JPA stuff. JPA is a Java Persistence API. Right? But otherwise, the best way to communicate is through Piazza. In fact, if you send me an email with a good question, I'm going to say, great question, let's take that over to Piazza. Why? So that everybody can get the benefit of the answer. Right? Not only that, but if somebody posts a question here, you can answer it, right? As long as you're not posting code, as long as you're not giving away solutions, things like that. Right? All right, where is the syllabus? There we go. Oh, there's the syllabus, sorry. All right. Otherwise, Learning Assistant program. Some of you might have become Learning Assistants for Computer Science 1 or 101 or something like that. Great, congratulations, welcome. Otherwise, the Learning Assistants are there to help you throughout the week. They're the ones who grade, they're the ones that help you in lab, etc. Right? You also have the UNL Writing Center. When we get to the technical writing section, we'll have somebody come in and help. Otherwise, this is the blurb that they want to share with everybody, that if you have any questions about writing, not only in this course, but any course, you can always go to the Writing Center and get some critique and feedback on your writing. They will not be editors for you. They will not proofread your stuff. There are automated tools for doing that kind of stuff. Spell checkers, for one, right? But they can give you feedback on, no, this is complete nonsense. I don't understand what you're doing here. Or maybe, have you thought about this, et cetera, et cetera. Right? Get help the right way through primary resources, lectures, lecture videos, required reading, labs, and Piazza, and of course, help hours throughout the week. Right? Any questions so far? No? Then I think that's everything that I wanted to go over. Yep. The only other thing, oh wow. The only other thing that I would suggest is, again, when you look at the assignments, especially the project as we come upon it, In each one of these phases, here's the assignments for this year. Let's just go to assignment 3 here. At the bottom, you'll see the rubric, the full rubric, exactly what we're grading for, right? And the point distribution. For example, design is way more important than correctness, right? It might work, right? You might get 100% correct answers, but if it isn't designed well, it isn't going to be a good submission, right? Otherwise, we also give you common errors. These are things not to do, that if we see them, they're probably going to be deducted over here, down here on the rubrics. So make sure that you're paying attention to all those things as we move along. Right? Oh, come on. All right. Any questions as I reload this? No? So then let's start talking about Python. Python is a programming language that was created back in 1989 by Guido van Rossum, right? Why did he create it? Well, why does anybody create a programming language? I hate that programming language. I hate that programming language. I hate that programming language. I'm going to make my own programming language, right? And now we've got yet another programming language, right? That does things differently. And he looked at one thing. I want that. I like that. I hate that. I like that. I hate that. And so he creates his own programming language. It is an interpreted language. It's a scripting language, meaning that it is not compiled. Unlike, say, C, where you write your program, you compile it, you link it, and it produces an executable program in binary. That doesn't happen. There are just-in-time compilers and partial compilers, but otherwise it's a scripting language. You just start running it, right? It is dynamically typed, meaning that over here in, say, Java, you create a variable called x. That has a type, int x. And you can only ever assign a variable of an integer type to it, 42. You can't assign hello to an integer type. But in Python, you can do whatever you want. In fact, let me open my demo over here. You want a variable, all right? X. Well, there's a variable called x. Well, let's assign it a value, 42. Done. It's an integer. Later on in the program, if you want to change it to, say, 3.14159, right? Now it's a double. Now it's a floating point value, right? If you want to change it again later on and make it into a string, you can. Hello, world. There, now it's a string, right? If you want to change it to a string using single quotes, you can do that too. Hello, world, right? There is no distinction in Python between those two. Single quotes, double quotes, it's all the same. As long as you're consistent. Double quotes need to be ended with double quotes, single quotes with single quotes, okay? But otherwise, that's what it means to be dynamically typed. The variable's value can change, but also its type. It goes from an integer to a double to a string and back and forth as much as you want. If that looks cool to you, it is a little bit cool, but it's also extremely problematic. What if I have a function that passes x into that function, and that function expects it to be an integer? Over there in Java, C, right, the compiler would find that out immediately. What happens in Python? It just fails when you get to that point, right? There is no checking, right? There are tools that you can use for static typing in Python, but they're not in common usage at all, right? That's what dynamically typed means. As I said, it supports integers, floats, strings. There's no difference between float and double because there is no keyword float. There is no keyword double. It is what it is. Doubles are 64-bit IEEE 754 numbers. Don't worry about that. That just means that I can type as much as I want, but only the first 16 digits are actually represented, right? In fact, let's show this. Print x. How do I run Python? Python demo. No, I'm not in the right directory here. 156. Python, and then this is called demo.py. Py short for Python. There we go. How many digits did it represent? Only 16. What about the rest of this garbage that I typed? Gone. Right? It ignored it. Right? That's in contrast to an integer, where you can go ahead and mash the keyboard as much as you want, right? As long as you're using a modern version of Python. Python 3 only. Print x. Arbitrary precision numbers for integers in Python, right? Built in. That's native support. They're first class. What we call that first class citizens. When a language supports something by default without having to bring in a library, it's a first class citizen, right? It's prioritized, right? What about printing this string? Right? There we go. It's a string. Right? What's not at the end here? See, folks? The null terminating character. You do not need to worry about that, just like you don't need to worry about that in Java. Right? So no null terminating characters at all. Right? Now you saw the good, now the bad. White space matters. Right? Let me come over here and show you what I mean. Oops, I mashed the keyboard and put in an extra space. Error, unexpected indentation. Right? White space matters as far as indentation goes. If you want to define a function here, this is a preview of what we'll do. Def say hello. This is a function. All it's going to do is say print hello, hello, and then print, there we go, print world. I'm only doing this on 2 different lines because I want 2 different lines. If you indent 4 spaces there, or I guess that, what was that, 4? 1, 2, 3, 4, there we go, and only 1 space there, that will not run, right? It doesn't know what you're talking about. Everything has to be aligned, and everything has to be aligned perfectly, right? Now your editor will generally do this for you. And cross your fingers and hope that your editor is consistent between using spaces and using what I just did, a tab. Because it will still not, it'll still work here, but that's probably because it changed my tab to spaces. Yep. Did you see that? I typed tab. I said tab. I want tabs, right? But it put in 1, 2, 3, 4 spaces. That's a smart editor there, right? But you might not have a smart editor, or you might have an editor with a different configuration, and it'll put something else differently, completely different in there, right? So white space matters, right? So get out your rulers and look at your screen and see if it works or not. There is a style guide. There's a link to it, right? It's called PEP 8, Python something whatever. Why is it called Python, by the way? It's nothing to do with snakes. Because Guido here was a Monty Python fan, right? And he named it after Monty Python, the British comedic group, right? So look it up if you've never heard of Monty Python, right? Otherwise, one of those styles is lower camel casing for variables and function names. If you see me violating that, okay, fine. Go ahead and call me out on it, and I'll try to fix it. Doing things like this, the way that Python wants you to do them, that's doing it the Pythonic way. When in Rome, you do things the Roman way. When in Python, you do it the Python way. When in Java, you do it the Java way, right? 4 spaces generally are for indentation. Not tabs, not 1, not 2, but 4 spaces, right? You can get into holy wars about this if you want to, but it is what it is, right? Function names are lower camel cased. Classes are supported, but they are upper camel cased, I think. Don't quote me on that, right? All right, so let's come back over here and let's go ahead and play around with this a little bit here because, okay, yeah, you can print, right? How would we have done this in, say, C instead? Print F, right, with a %d here because that's going to be an integer. %d is the placeholder for that. And then we would have put a semicolon at the end of this. Do you see what my editor is doing with that semicolon right there? It's kind of making it magenta, right? And then it's italicizing it. Why? It's warning me that that's not a Python thing, right? Python does not end things with a semicolon, for better or worse. Again, it's one of those icky things. I like punctuation, right? Imagine reading the newspaper with no periods, with no exclamation points and no question marks, right? It's not very legible, right? Now try reading code without the same kind of punctuation, right? It's more difficult to read, right? People argue, no, it's easier to read because there's less stuff there. No, the stuff there matters, right? It's performing a purpose, right? But it is what it is. If you put it there, it will run. It won't, but it'll ignore it, right? Let's put at the top here that you can do single quote, or you can do single line comments, right? So single line comments in Java, C is going to be, is that a backslash or a forward slash? Forward slashes. right? That's not supported in Python, right? That will be a compiler error. Hello, my program, right? Not a compiler error, but an interpreter error. What is that? So single line comments are actually hashes, right? And now you see the style has changed there. You can have multi-line comments. Maybe this is a multi-line comment, but it's not being treated as such. Let's see if we can do that. Nope, you can't. So how do you do this instead? Well, you can do this and then have another hash at the beginning of the next one, next line, and then next line. But you don't generally do that. So what you do is this little trick here. In fact, this is how you do documentation as well. We'll get to that later. 1, 2, 3 quotes. 1, 2, 3 quotes. That is it's called a doc string. You can put that into a variable, right? And now a blank line is stored in X. Or you can just have a string by itself, right? This is a multi-line string. Ultimately, it is ignored by the compiler or the interpreter because it is not assigned to any variable. Right? So it's acting. Oops, sorry. Print. Oh, let's get rid of that for now. Right? It is acting like a multi-line comment. Remember, it is 1, 2, 3 quotes. 2 quotes don't work. Right? 1 quote works, but then that's just a regular string, not a multi-line string, and it doesn't know what to do with it. If I put all that stuff, 1 quote, 1 double quote, 1 double quote, and I put it all on the same line with end-line characters, that would treat it as 1 line. Right? But multi-line over multi-lines means 3 quotes. That's supported in Java, by the way, too. Right? Okay. So just so we know how to do this before we leave here, how do I do a printf style? In other words, I don't want to print, let's do it down here with pi instead. Right? Oops. Printf, %.2f, end the line, and then y. What would that do in C? That would print out y with at most 2 decimal places of accuracy. Right? We can't do that in Python because Python does not have printf functions. It has what's called a formatted string, though. So let me change this a little bit. Print is the only print function. Right? Put an f in front of your string. Printf instead of right? Format, right? And you can do something like this. Now I don't need the formatting. Let me first try it with this, with y. There we go. So I put the variable in curly brackets. That's going to mean that the formatted string, it's going to take y, whatever the value stored in that variable is, and it's going to format it according to that formatting. Right? Let's run this. I'll just show you here. Right? 3.14159. But it's not to 2 decimals of accuracy. So you can add those placeholders just like printf. I don't know, 20.2, right? And an f. There we go. Now that will print out, oops. No, it should be colon, sorry. There we go. Colon, and then we go. There. 3.14. Only 2 decimals of accuracy. That's what this 0.2 is doing. But it's also printing out a minimum of 20 columns. I count 1, 2, 3, 4 columns for the number. So how many spaces are preceding this, do you think? 16, right? And that's how you can get printf style formatting. Just use formatted strings, right? Just a little bit slightly different syntax. How would you do it for anything else? Say percent, or not percent, but just x by itself. There we go. Prints it like that. If you want to print a string, there is no formatting for strings. It's because strings are what they are. So whatever, hello, oops, s is equal to my name, yay. There we go, and s. Right. There we go, and my name is at the very end there, Chris. Otherwise, if you put it in just s, that's not a variable. That's just s at the end. Right? So that's basic output. You're not going to be doing too much basic input, but you will do that in your first lab. Okay. Any questions? Otherwise, that's your very first introduction to some basics in Python. We'll continue Python on Wednesday.